Let's solve this simple simultaneous equation. Okay, if you notice, let's put this one in equation 1. Let's put this one in equation what? Equation 2. Of course, x plus y is equal to 3. This is in a linear form. This is easy to solve. Okay, but the major problem is in equation 1. If you notice, our x and y are in their what? In their exponential form. So how do we solve it? Since if you notice, this basis, this one basis, but it's only this 42 that is what? That is extensional, because it's not in what? In exponential form. So what we're going to do is that we're going to look for two numbers that if you multiply both of them together, you're going to have 42. Okay, and one of those numbers must have 6, so that because we want to actually have this basis, this basis there. So one of the number that we are going to consider is what must have 6. So the two numbers that you can use is what 6 times what times 7. Okay, so 6 times 7 can give me exactly 42. Okay, so let's concentrate on this equation 1. So this can be written as 6 raised to power s plus 6 raised to power y is equal to what? 6 times 7. Okay, but if you notice, I needed only 6 because I want to the numbers, I want to have these exponents. I want the numbers that I will get, I want it to be in what? In exponential form. So I needed only 6. So because of that, I'm going to break this 7 into two parts, whereby one we have 6. Okay, one other number we have 6, because basically I needed 6 as a number. So this can be written as 6 raised to power s plus 6 raised to power y is equal to 6 times bracket 6 plus 1. Okay, of course 6 plus 1 is 7. Okay, so the 7 will successfully broken into two parts. But definitely I don't need 1, so I can distribute. This 6 into these terms. So because of that, I can get 6 times 6 is 36. Okay, but since we are considering the what in the exponential form, 6 raised to power 2 to get what? To get 36. So it's writing 6 raised to power 2. Okay, so because I needed it in what? In exponential form. So and then second part, which is this one, 6 raised to power what? Power 1. Okay, because 6 times 1 is 6. So in exponential form, 6 are writing 6 raised to power 1. So as the case is, if you notice, this plus, this one is what? Plus. Okay, and both of them are written what? In exponential form. Of course, this is commutative. I can decide to revise it. I can decide to say 6 raised to power 1 plus 6 raised to power 2. Okay, because it's commutative in nature. So so I will say, for me to get my value of x now, since all of them are in raised to power in base 6, I can compare them together. So I can conveniently say that my x is equal to 2. Okay, because I can compare the terms together since the base are equal. Okay, and I can conveniently say that my y is equal to what? It's equal to 1. Okay. Okay, so I can also say that I can say or. Okay, I can also say that 6 raised to power x plus 6 raised to power y is equal to 6 raised to power 1 plus 6 raised to power 2. They are basically the same thing. So I can say my s is equal to 1 and my y is equal to 2. They are basically the same thing. Okay, so how do we check if our answer is correct? You can check if our answer is correct in what? In equation 2, because either way, if I add them together, you get our final answer. If our s is 2, if our y is what? Is 1. So our answer is what? Is 3. So that means we are what? Correct. And if we chose this one, if our s is 1 and if our y is what? Is 2, automatically we still get our 3. Okay, so this is easy way to tackle this type of question. Okay, of course, if you look at it at a glance, it's kind of confusing, but following this particular step will enable you to what, to solve and able to solve any type of simultaneous equation that have to do with what, exponents. Okay, so if you like my video, don't forget to subscribe, like and follow my channel, James Maths Academy. I can see you next time. Thank you.